Hello, we're going to go into SciFinder web again for a little bit more detailed look now into structure searching. In my previous video we ended that session with looking at an exact structure. We drew the structure of caffeine and we searched that. So let's explore the chemical structure searching options a little bit further. Now on my screen now I'm at the window for chemical structure searching, and in fact we can see where we are precisely by the presence of these blue boxes, and I'm certainly on this tab right here. So let's go. If I want to draw a structure, then I need to click on the box. And I can, of course, as we've seen previously, use these tools such as the atom and the pencil, as well as what we have along the bottom here for ring systems and different bond types. We can use these to draw our structures. But we also have some other options if we want to create a structure. And the button that I want to point out to you is this, what we call the text to structure button. And when I click on this, I can enter in a CAS registry number, a smile string or inchi as well, and then I can create the structure from this. Okay, so I'm going to enter in CAS registry number. I click on OK, and here we go. Here's our structure that's been assembled for us. Now this structure is a drug called retigabine. It was manufactured as an anticonvulsant drug and has been used for many health conditions previously, such as epilepsy and so on. So if I want to look at this drug, I'm interested in it and I want to explore this, then of course I can first of all, I can go back and I can search this as an exact search, and in fact let's do that quickly so we can see what we get. If I search for this, then indeed I get 22 substances in total. Here is precisely what I've drawn right as answer number 1, because we have our sort by is in terms of relevancy. But we also have other things in here as well, and in fact we can see these are hydrochloride forms of this drug as well. So when we do an exact search, we will find what we've drawn, plus also any other salts, maybe isotope forms or other stereo forms, mixtures and so on. So it is not unusual when you do an exact search to get more than one answer. Okay, let's go back. I'm going to use that breadcrumb trail. And this time I'm going to run this as a substructure search. And let's see what we get now. Okay, we've now gone from 22 substances to 127. And in fact, what we have in this answer set, we will have those 22 that we found when we did an exact search. But we will also find substances where retigabine is present, that core structure is there, but there may be other things substituted onto that structure. And in fact, if we look at exploring some of these and we change this order, now we're going to keep it in terms of relevancy, but if we use this little blue arrow that's to the right hand side, we can now reverse this answer set. And what this will show us is at the top now we have what we've drawn, plus of course we can see in fact that there are other things substituted on this core structure. So when you use this arrow, we can now say sort from the most relevant to the least relevant, and that is what we are seeing in this answer set. Okay, I'm going to get the references for all of these. I'm not going to make any selections. I'm going to take all of them. Get these. So we have 826 references that within these references will contain at least one of the structures that were found when I did my structure search. Now I just want to point out across on this left hand side where we have analyze, refine and categorize, there are a few ways that we can drill down into this answer set to find more focused answers. And the one that I'm just going to point out for this session is under Analyze. And if we change it from the default of author name, and we're going to come down to concept heading and click on that, then what this does, this looks through these answers that we have found, and it says this is the main, or these are the main concepts that are discussed within these documents. And it's not surprising, of course, given what I've searched, that high on that list is anticonvulsants, but also I see epilepsy, seizures, and so on, and I would expect to see that. So we have 262 documents in this answer set where the discussion around anticonvulsants is a major part of that document. Okay, so if I'm interested in this drug and maybe I think, okay, well, that's good, but perhaps I may be interested in exploring that drug a little bit further. And if we go back to our structure and we take a look at this, let's open this up again. And maybe we'll say, okay, well, we've got ethyl here, we've got, 2 carbons, we have the phenyl ring here. Maybe we'd be interested if perhaps that might not necessarily be phenyl, but perhaps could be a pyridyl ring or some other ring system. Likewise, where we have this NH2 here, maybe we'd also be interested where that may not be NH2, but perhaps it could be that, or maybe also a halogen or a cyano group. Then what we can then do is we can draw what we call a generic structure that will reflect what we have here, but it will also allow for a few other things as well. And I'm going to bring in a generic structure that I've previously drawn based on this drug structure. So let's take a look at that. So I'm going to import my file. This is one that I've drawn. And what we see here, we've got, instead of the ethyl, we've got alkyl. This is a variable that we can use. I've also, instead of drawing in that phenyl ring, I've used CY, and we can see that means any cycle. And then also I have an R1 group in here, which says, yes, I'm interested in NH2, but I would also be interested in structures that may have a cyano group or a halogen and so on. And we can draw these very easily using these groups here. We've already spoken, of course, previously about using the atoms and also the shortcuts, which allows us to very quickly select maybe a methyl group or a cyano group and so on. But we can also use these here. And under X, if I click on the X here, I see I have a number of variables where I can click on X for any halogen. Or maybe I want to say AK, any carbon chain. I've used these in my structure. Any cycle. Maybe any heterocycle if I'm only interested in heterocyclic structures. So I can use these in my structure drawing. And I have 2 right here, CY and also the AK. But I am also able to draw what we call an R group, which says I want to decide the number of options that can be substituted on this cyclic ring. And I can use or create these R groups with the R group tool. If I click on here, you can see I already have R1 because that's already there in my structure, but I can add quite a few more other R groups if I wish. And I can create them. So if I want to say, for example, an R2, I won't use this in my structure, but if I want to create another group, then I can either select maybe from the atom palette, or I can use my variables, any halogen, and also the shortcuts. And I can select whatever I need to do to populate this R2 group. Anyway, let's go ahead and run this structure. So I'm going to click on OK. Here we see it, and let's go ahead and search. Okay, wow, 10,000 substances. But of course that's not surprising, because I have drawn a very generic structure and I am searching it against real structures within SciFinder, and I am going to find a lot more than had I simply searched for the retigabene as a substructure search. I have much more answers now. But let's go ahead and get the references from these anyway. So I'm going to come up here, click on Get References. Again, I'm not going to limit it at all. I'm going to take all of them. And we have just short of 3,000 references, which of course is a lot. But as we've seen, we can also now go and use our Analyze tool, and maybe we want to say, okay, let's take a look at these concept headings again and see what we have reflected in our answer set. Now in terms of the anticonvulsants, we had, I think it was 262 when I searched for retigabene as a substructure search, and we can see that number has increased. We also have anti-tumor agents, analgesics, and so on represented in this answer set. Now in SciFinder, when you look at the Analyze options, it'll give you the top 10, but if I do want to see more, then I can click on Show More, and I will see a much longer list now of what we have in here. So if I, for example, I'm interested in anticonvulsants, but perhaps also I want to, maybe explore epilepsy, anti-inflammatory agents, whatever I want to do, then I can make this selection and then apply that to my search, which now brings me down my answers quite substantially. Now, what I need to do, of course, if I now want to work within this answer set, is I want to make sure that I click on Keep Analysis, and now I have 478 references across journals, patents, and so on that will include substances based on what I have actually drawn in my search. So I hope this has shown the difference in doing an exact search compared to a substructure, and then of course using that structure that I used initially, creating a more generic representation and broadening out the search to pick up further information that I may need. And that concludes this second video on the SciFinder web training, and I hope you'll join me again for another video on reaction searching. Thank you very much.